everyone, welcome to Engineering Archives. Let us look at the first practice problem for this chapter, force vectors. So this problem says, express the position vector r in Cartesian vector form, then determine its magnitude and coordinate direction angles. As you can see, this vector starts from the point A and ends at the point B. And we can also see that they have given us some of the length measurements along the x, y, and z axes. So let's see what length measurements we can find from this diagram. First of all, we can easily notice that we have the length measurement provided to us for this vector along the y-axis, and that is going to be this length, which is 8 feet, minus this length, which is 5 feet. So this is going to give us 3 feet along the y-axis. So we can write that part of the Cartesian vector form down, right? So, or in other words, 3j. Okay, and it's in the positive y direction, so the sign is going to be positive. All right. Now let's work on the length along the x-axis. So to find this length, we notice that they haven't provided us the length measurement for this vector AB along the x-axis, but they have given us the angles, and we can find this length using these angles. So the first thing we can do is we can write down this length, which is 5 feet, and once we project this length on this line, we get 5 feet cos of 20 degrees. Now that we have projected this length on this line, we can project this line upon the x-axis, and to do that we will simply multiply this by sine of this angle, which is 30 degrees. So let me repeat that. First of all, we do 5 feet cos of 20 degrees, that projects this length on this line, and then we do sine of 30 degrees, sine of 30 degrees, and that projects this length on the x-axis. This is a procedure that we have been doing in the previous problems, and you can simply perfect this by practice. So this gives us 2.35 feet. But notice that the vector AB is traveling in the negative x direction, so we're going to add a negative sign. So let's put this in our Cartesian vector form. Negative 2.35 I. Okay. Sorry, B. Alright, lastly we need the length measurement along the z-axis. To find that, we can see that they have given us half of the length that we need. That is, they have given us the length vector AB above the y-axis, which is 2 feet, but they haven't given us the length below the y-axis. And we can find this length, the one below, using these angles. And notice that we can simply find that length by just using the trigonometric identity, which is 5 feet sine of 20 degrees. That would project this length of 5 feet on this line, and this line is exactly the length that we need. So once we do that, we get 5 feet sine of 20 degrees. This is the length below the y-axis, and to this we add 2 feet, and we get the total length in the z direction, which is equal to 3.71. And finally we can add this measurement in our Cartesian vector form, plus 3.71 k. Now that we have the Cartesian vector form, we can move on to find the magnitude of this length vector AB. So to find the magnitude, we will simply use the resultant or the magnitude formula, that is magnitude of the length vector from A to B is equal to under root sum of the squares of all lengths in each direction. So under root sum of the squares of the components of this vector in each x, y, and z direction. And once we solve this on a calculator, we get 5.31 feet. Okay, and now let's move on to the last part of the question, that also wants us to calculate the coordinate direction angles. And to calculate those, we will need to use the coordinate direction angle formula. So let's do that. So cos of the coordinate direction angle for the length vector from A to B for the x-axis would be equal to the component of the vector AB in the x direction, and from this Cartesian vector form we can see that component is negative 2.35 divided by the magnitude of the vector, which is 5.31. Solving for theta x, we get 116.3 degrees. Now marking this angle on the diagram just for the sake of clarity, just for the sake of understanding, we can see that this angle basically is the angle that starts from this vector, and it goes, or it's the angle that starts from the x-axis and goes to the angle right here. So this is the angle which connects the vector with the x-axis, and it is 116.3 degrees. Okay, so moving on to the angle for the y-axis, that is equal to the component along the y-axis, which is 3 feet divided by the total magnitude, which is 5.31. Solving for theta y, we get 55.6. And marking this angle on this diagram, we can see that this angle would start from this vector and end on the y-axis. Lastly, let's solve for the angle that connects this vector and the z-axis. That should be equal to the component along the z-axis divided by the magnitude of the vector. Solving for this angle, we get 45.7. And once again, looking at this diagram, we can see that this is the angle that connects the vector AB to the z-axis. So this was a simple and easy procedure for this video. Thank you very much. See you in the next video.